Hello, this is Algebra 2, Chapter 7, Section 1. We're in page 2 of the notes. We have before us example 1, where we're meant to graph this exponential function. Now, this has changed a little bit from the box on the bottom because our function is y equals 1/4 times 6 to the x. So we're now multiplying by a factor. We'll want to go ahead and be a little bit careful here. Good ideas at first are to let x equals 0 and x equals 1 and figure out the y values. So when x equals 0, the y value is 1/4 because 6 to the 0 is 1, and then that is multiplied by 1/4, so it's 1/4, or if you prefer 0.25, same thing. And then when x equals 1, we're going to get 6 to the 1, which is 6, and that's multiplied by 1/4. That makes 3/2. So it says plot 0, 1/4, which is about yay-ish, and 1, 3/2, which is yay-ish. There we go, we got a couple dots. Then from left to right, draw a curve that begins just, and this needs to be just above the x-axis, passes through the 2 points, and moves up to the right. I'm not sure why they left this wording as something that you're supposed to be able to fill in. Maybe if you look at the book it has a similar construction. But either way, we're moving from the left through those above the x-axis, through the 2 points, and up to the right. There we go. Make sure we have arrows on both ends. And then we do want to point out that there's an asymptote right here. Each of these exponential graphs has an asymptote. And in this case, we'll start right there on the x-axis. So that's all for example 1. If we move over to example 2, you see we have a different, slightly more complicated piece of business here. Now the first thing I want to do is talk about the general construction they have right above example 2. It says y equals ab, and then it says to the x minus h. I'd like you to, in your mind at least, go ahead and put parentheses around x minus h, because I think you can see, like before, we're subtracting inside this general formula system, and so one thing I've always told you guys is if there are parentheses, it's kind of backwards from how it should be. So if you mentally put parentheses around there, it follows that pattern. That means on this actual example 2, it's 3 to the x minus 2 with x minus 2 in parentheses. Now the book solution is to begin with this general 2 times 3 to the x business. We can try it their way. It's not my most favoritist, but there's a lot there that might be right here. So first we're going to begin with x equals 0. So 3 to the 0 is 1, times 2 is 2, so we have the point 0, 2. And then when x equals 1, 3 to the 1 is 3, times 2, that makes 6. So we've got the 2 points, 0, 2, and 1, 6. So 0, 2, and 1, 6. Boom. And then we're supposed to make the graph, and that comes off the x-axis, through the points, and up to the right. Now this is nice. That's a nice graph. That is not the graph we're asking for, though. This is that simpler graph, y equals 2 times 3 to the x. But because of the x minus 2 inside the exponent, we're going to translate that graph right two units, and because of the minus 2 outside the exponent, we're going to go down 2 units. Boom. Now, go ahead and take the points that we had before and move them right 2, and then down 2, and maybe purple for the new graph. Boom, and boom. Those are the new points. Now, one thing that isn't said there, and they really should have said, is that the original graph, the earlier graph, had this asymptote on the x-axis. When you move that horizontal line right 2, nothing happens, to be honest. But it does go down 2 also, just like all the points did. So our new asymptote is down at -2. So for our graph, we're going to come off the asymptote, swing through the points, and continue up and to the right, making sure that we actually have arrows on both ends of the graph. Boom. The graph's asymptote is the line. This is why I was making kind of a big deal about that asymptote business, because the asymptote moved down, so it's the line y equals -2, and the domain is all real numbers. I have no idea why the book decided to tell you the domain is all real blank. Doesn't make sense. It wouldn't be all real chickens or all real tow trucks, but nevertheless. And the range is y is greater than -2. Remember, the graph doesn't ever actually touch the asymptote. It starts right above the asymptote. So that's why it's y is greater than -2. All right, that's example 2. Now, let's look at the checkpoint. If we were to follow the way the book had it, we're going to begin with a slightly simpler graph. Y equals 2 times 4 to the x. And that has a couple fun points, right? That has the point 0, let's see, 4 to the 0 is 1 times 2, 0, 2, and it also has the point 1, 4 to the 1 is 4 times 2, 1, 8. Boom. So 0, 2, 1, 8. So 0, 2, boom. 1, 2, 4, 6, 8. Boom. Make our graph. Boom, boom. Boom, boom. Arrows on the end. And remembering that there is that horizontal asymptote on the x-axis. That's great, but that's not actually the right graph. That's the more basic graph. Now, because of the x plus 1 in parentheses, and maybe you went ahead and added the parentheses, our new graph is going to go left 1. So each of those dots, you can go ahead and think of them being moved left 1. But don't get excited and draw them quite yet, because we also need to go, boom, -3 outside the exponent needs to go down 3. So each of those dots also goes down 3. 1, 2, 3. 1, 2, 3. Boom, dot, boom, dot. But that asymptote also moves down 3. 1, 2, 3. Asymptote's way down here now. So, exciting times. Here comes the graph off the asymptote, through the first point. Makes a sharp turn. Actually, not a corner sharp turn, but a steep turn through the second point and off to infinity. And that's our new graph, except we have to talk about both the domain and range. So the domain is a question they're just trying to waste your time with here. The domain is all real numbers. Done. Range. Now remember, the asymptote was way down at -3 for this one. Oops, forgot the arrows. There we go. The asymptote was way down at -3, so the range is y is greater than negative 3. All right, that took a little while, but those are some examples of moving these exponential graphs. We got a checkpoint there. Between example 2 and that first checkpoint, I'm hoping you're seeing the pattern on how to move graphs around. Thank you for watching.